Okay, for the alum experiment. My crystals have not completely formed yet, but if you look closely, you can see small specks of crystals at the bottom, um, which to me I perceive as seeds of nucleation. I decided to store the vial of solution just inside the door of my closet slash dresser, which should be a location that is undisturbed enough as far as the vibrations go, as well as excess light. But the process of recrystallization basically is built on the tendency of solids to increase in solubility due to increases in temperature. Um, and the first step we did was we added aluminum foil to a K2OH solution, which dissolves the aluminum, but leaves a few residual impurities, which are filtered out using vacuum filtration. Next, we add a portion of the sulfuric acid, which precipitates an aluminum hydroxide, which is a solid that forms in the solution. And the next step is important for getting rid of this solid precipitate, and that's heating the solution because it raises the solubility of the aluminum hydroxide. Despite adding in this step also the rest of the sulfuric acid, eventually all of the solid precipitate is dissolved in the solution. The next step is putting the solution in an ice bath, which is crucial because the ice bath creates an alum precipitate, which is our desired substance. And this is because lowering the temperature lowers the solubility of the solute, in this case alum. Furthermore, the alum has a higher crystallization point than the freezing point of the solution, which allows the substance, alum, to crystallize while the solution is still liquid. Lastly, the last important point I want to make is when we use our 50-50 ethanol and water mixture to rinse the solution in the Buckner funnel. This is because alum is insoluble in ethanol, but soluble in water. So the ethanol in the mixture prevents the alum from dissolving in the 50-50 ethanol water mixture when it's being rinsed off. This way all the alum product is conserved when rinsing, but the water is also necessary to dissolve any residual reagents, like remaining non-precipitated alum that's been left over. To grow crystals of NaCl, all you would have to do is obtain a glass container that's clean and fill it with distilled water. And you want to heat this distilled water until it's near the point of boiling. At this point, you want to add NaCl, table salt, to the solution, and you want to mix until no more salt will dissolve. And there should still be some salt left at the bottom, a few salt particles perhaps. At this point, we can be sure that the solution is supersaturated, which is the most practical way to method to ensure that the solution is sufficiently saturated. Now all you would have to do is let the solution cool, ideally in a place that's undisturbed, again, because vibrations can induce nucleation too rapidly, and many small crystals would form in this case. However, for more pure and large crystals, it's better to filter the supersaturated solution so that all the undissolved salt is removed from the original solution. And this is because with residual reagents, crystals will incorporate them into the structure of the crystal lattice, which ultimately results with a more impure crystal. Lastly, there are many different ways to grow a crystal. With some, the intent is to form crystals in a very short period of time, similar to the process I mentioned for growing NaCl crystals. One other way that yields more pure and sizable crystals requires a lot more time, first of all. In this method, the desired solute is first supersaturated in solution and then filtered to remove all of the undesired residual substances, primarily the undissolved solute. And now there are three important steps. The first is to use a seed crystal, which is configured so that the crystal is suspended in the solution, hanging from a string or thread or something like that. The next step is to place some sort of covering over the opening of the container, such as a chem wipe, that allows airflow, but limits it enough to maintain a slow rate of evaporation, which is important for maintaining pure crystal growth. And the last step is to store the solution in a cold place where you are sure that the solution will not freeze. So maybe like a fridge. The seed crystal acts as a perfect site for nucleation of the crystals, and most of all, induces crystal formation with a model crystal lattice as the base rather than any other substance, which would lead to more irregularities in the crystal lattice, and that would deviate from an ideal crystal lattice structure. And this process is more likely to produce crystals with minimized impurities that are more sizable than the first alternative method that I mentioned. And my source for this, a lot of it was a webpage created by the Department of Chemistry at MIT, which I found when I was trying to fully grasp the concepts that manifest in this experiment, and the source proved to be very useful.